So in fact, when we're thinking about laser beams, we can exploit the fact that this is something called coherent radiation, which means that, as I mentioned before, the spatial structure is constrained to be some specific kinds of shapes. But also there's a couple of other parameters that now we can play with. One is called phase. And if you think about light being a wave, and we can imagine an undulating waveform, then the spacing between the peaks of this wave is what we essentially refer to as the phase. That is where it's related. And that we can use in coherent radiation. So that's another degree of freedom that we can exploit. And in fact, these two, the spatial structure in terms of intensity and phase are tied to each other. One kind of influences the other. So that allows us to structure light in specific ways that will be more stable on propagation, like I mentioned before, which is excellent for communication, for example. And there's another parameter of light that we can also play with. And that is polarization, which might be familiar to you from polarized sunglasses, for example, that help you with reducing glare from certain kinds of surfaces that are sort of grazing incidence surfaces. So, for example, car windshields in front of you, that would be one application. Or also, in fact, in most modern LCD screens, there will be a polarizing element that actually allows you to get the images of your screen.